Good afternoon and welcome to this presentation of the Fairfax County typical deck details. This presentation is based off of the most current edition of the Virginia Construction Code, which is the 2021 edition. My name is Kyle Kratzer and I am going to walk you through this Fairfax original document today. I have been involved with the deck detail for the last 8 years, and I hope that I can help you demystify this sometimes confusing document. So today we're going to try to cover defining the scope, understanding how to navigate the document, and discussing the multiple materials approved for use. Throughout this, we're going to practice utilizing some of the various charts, and hopefully at the end of it, you will be able to navigate it unassisted. So the first thing we're going to cover isn't what's in the deck detail, but what's excluded from the deck detail. In this case, we're talking about multi-story decks or decks that are supported on the same footing. We are talking about hot tubs, privacy screens, built-in seating, and built-in planters. All of these are prohibited from the deck details. However, that does not mean that they can't be built. They would just have to be built outside of the deck detail, and by that I mean they would be submitted for plan review and permitted on through the normal plan review process. Another couple keynotes to keep in mind is that you have to ensure that you're using the proper fasteners. So in this case, we're talking about galvanized nails or stainless steel nails as well as hangers. The purpose of that is to make sure that the chemical composition of the fasteners and hangers mix with the pressure-treated wood that is utilized to build outdoor structures. If you are using a product that is not approved through the building code, in this case we're talking composite railing or surface-mounted guardrail systems, you have to ensure that you are submitting an ICC ES evaluation report or another approved nationally recognized testing report. So, jumping right in, let's start talking about the thing that you're going to notice first, your decking. The decking that is approved in the typical deck details include 5/4 boards. In this case, when we say 5/4, we're talking about wood that is 1.25 inches thick. We're talking about your traditional 2x4s or 2x6s. And we're also talking about plastic composites or PVC board. That's going to be your engineered products. And again, while they are approved, and we do have them in here, you do need to ensure that you are providing that testing report to show that it is approved for use. This table here in Table 1 gives you an idea of what joist spacing, and we'll get into what joists are here in a second, what joist spacing you have to provide in order to utilize those materials. And we provided you 2 categories, both perpendicular and angular. These materials are only approved to span a certain rating, which is why we have to differentiate. How do you fasten those deck boards to the supporting members? So in this case, you're talking about either 2 8D nails per joist or 2 number 8 screws per joist. Those are going to be used for your surface mounted penetration, so going directly through the product into the joist. We also allow for another option, which are side mounted hidden fasteners, which would allow you to attach into a groove that you find in some composite materials, into the groove, and fasten in between the deck boards so that you don't see every fastener hole. The one stipulation to using the hidden fasteners is that you have to provide some additional bracing underneath all decks that are more than 30 inches above ground level. And the reason why that's important is when you fasten with the traditional piercing method, you are tying every single deck board into every single joist and creating a rigid diaphragm that prevents sway in the deck. With the hidden fasteners and these grip type fasteners, it's not as strong a connection. So we require these braces underneath with 2 fasteners in each joist to try to recreate that rigid diaphragm. So another important thing to consider when you are going through your deck is safety glazing. When you construct a deck, sometimes you are creating hazardous locations in your window areas, and those have to be protected. In this case, we're talking about 2 situations where the most common hazards are created. One is at stair locations, and if you look at the checkered area behind me, you'll see you have a 36-inch minimum height down the stairs and up to 60 inches out from the bottom of the landing that is identified as a hazardous area. Any window pane in that area has to be protected by safety glazing. Additionally, if you happen to have a window located on your deck surface that meets the following 4 criteria, that would also be required to be safety glazed. In this case, we're talking about an individual pane that is over 9 square feet, 18 inches or less to the walking surface, and more than 36 inches to the walking surface. That is an area that is identified as hazardous. The 4th item is within 30 inches of the walking surface. In this case, we're talking decks that end up going right up to that window are going to clearly be in that hazardous area. If you have a window that's just outside of that walking surface and there is a guardrail between you and that window location, that would no longer be considered a hazardous location. You also have a couple electrical requirements to keep in mind for your decks. One is that within the perimeter of every deck, within 6.5 feet of that deck surface, you are required to have a ground fault protected receptacle outlet. That is to serve the function of the deck. You are also required to provide lighting at your stair locations. And that can be achieved through several different methods. One is a light at your exterior door, as long as that light illuminates the stairs. Another would be built-in low voltage lighting within each rise of the stair, so that the treads are illuminated. And then outside of that, as products continue to evolve, we would have to evaluate that on a case-by-case basis. Next, we're going to talk about joists. And what is a joist? Well, a joist is the supporting member that supports the decking boards. And when we talk about joists, we have to talk about joist span. And in this particular case, we're talking about the distance from support to support. So deck joists have to be supported on at least 2 points, whether that's from a ledger attachment or bearing under or to the side of a beam. For joists that are supported by a beam, a dropped beam, you are allowed to cantilever or overhang up to 1/4 of the span past that beam without a support on the other side. In Table 2, we talk about what that joist span is allowed to be. So in this case, if you were using a 2x8 joist with your joists 16 inches on center, which is what the 12, the 16, and the 24 stand for, the on-center spacing, you would be allowed to span 11 feet 10 inches. On the other side of that table, you'll see the allowable overhang, and depending on what your span is, tells you how far you are able to cantilever or overhang. Couple notes for joists. When you do have a dropped beam scenario, like we see in these two exhibits here on the right, you have to provide blocking for all overhangs greater than 2 feet. And that blocking has to cover at least 60% of the joist height. And the reason why is when you have joists with a long cantilever, you have a weakened point right at that connection to the beam. And we're trying to prevent the joist from rolling. So by providing the blocking at least 60% of the height, you significantly reduce the ability for those joists to roll. When you attach a continuous rim joist, and when we're talking about a rim joist here, we're talking about the board that connects all the joists together on the outside. You have to make sure that you are attaching each joist to the rim joist with 3 10D nails or 3 number 10 3-inch wood screws. And again, all of this is to help prevent the rolling. If you have a deck that is utilizing 2x6 joists, you have to be careful because you cannot attach a guardrail system to those deck joists. So if you know you have a situation where a guardrail is required, I strongly recommend considering upsizing your joists, even if it is compliant with a 2x6. I strongly recommend increasing that size to a 2x8 so that you can attach your guardrail system. If you have a deck large enough that you are in need of overlapping your joists over top of a beam, make sure that you are overlapping them at least the width of the beam and connecting those joists by no less than 3 10D screws. In a perfect world, you never have deck projections. However, in reality, homes are not always rectangular and have flat walls. So you may run into a situation with your deck where you have to frame around a projection. In this case, possibly a chimney or a bay window. Sometimes you have some kind of other item that you want to avoid. We do have a detail for that. And in this case, you are allowed to, we have a built-in design for up to a 6-foot maximum span and 3-foot maximum depth of projection in which we give you a detail to frame around. What you need to do is triple the joist beside the projection on either side, and it allows you to provide a 2-ply header joist to frame around that. If you are attaching to a ledger, one thing you have to be leery of is that you are required to provide additional fasteners into the ledger at both sides of that connection. And we'll talk about the ledger connection here in a little bit. So, joist hangers. When you are utilizing a ledger or a flush beam, you will need to use a mechanical fastener. In this case, we are talking about a joist hanger. And there are several things that you need to be careful of when using a joist hanger. The first is ensure that you're using the proper joist hanger. Yes, you can absolutely go to your local hardware store and find a very inexpensive or relatively inexpensive 2x4 hanger that looks like it should work for a 2x12. However, just like I had mentioned with the 60% rule for the blocking, if you use the wrong hanger on a joist that is too deep, you have not effectively prevented the rolling potential of that joist. So make sure you're using the correct hanger that encompasses enough of that joist. Do not field modify the hanger. Yes, there will be situations where a hanger does not fit correctly. And unfortunately, you may have to look into other ways to achieve that, whether you have to move a fastener in your ledger or come up with another solution, but you cannot modify these hangers. These hangers are engineered products and they are only guaranteed to work the way they're designed. Additionally, if you look here at the bottom left, you'll see this clip mechanical connector. That mechanical connector is not designed to support a vertical load. It is only designed to fasten a vertical joist to a top plate. So one thing you have to be leery of or be aware of is using the correct hanger. In a situation like that, which typically you see or we see, where you are trying to attach an end joist to the edge of the ledger, is using a concealed flange hanger, which looks something like this. As you can see, the hangers, or the nailing flanges, are turned in, which allows for you to install the fasteners and then set the joist in place. That looks a little bit different from your traditional hanger, which looks like this, where the flanges are on the outside. So next we're going to cover the joist to beam connection. For the Fairfax County typical deck details, we require a mechanical connector to connect all joist to beam connections. While this does exceed what is allowed through the Virginia Construction Code, it does ensure the proper connection and make it easier for somebody who is attempting to do their own deck construction. The connectors we're referring to are a simple H2A or what is known as a hurricane tie, which is this connector right here. What you would do is you would connect it to the joist where you have these 5 fastener holes, and then the other side would end up going into the joist with the same 5 requirements. This ensures a proper connection and again helps resist the rolling as well as any uplift that is imposed on the deck joists. If you look at the example here, you'll see that the joists sitting on top of the beam are required to have that mechanical connector, but a joist that is level with that beam would have the hanger that we spoke of earlier. So let's do a review real quick before we get too far ahead. What size joist would you need for a deck that is a freestanding deck with joists that are 16 inches on center? You have 11 feet 6 inches between the beams. You have a 2-foot overhang at the house and a 2-foot 6-inch overhang at the front of the deck. And when I talk about a freestanding deck, I'm talking about a deck that is constructed and supported completely independent of your house or adjoining structure. For this, we're going to go to Table 2, which covers our deck joist spacing or sizing. So when we go to Table 2, we are utilizing 16 inches on center. And to reach that 11 feet 6 inches, we would go down to 2x8. So that allows us a 4-inch surplus. So when we go there, looking for that overhang, because our total distance is greater than 10 but less than 12, gives us 2 feet 3 inches. But that's a problem, because we said one of our cantilevers was 2 feet 6 inches. So in this case, you would then have to upsize to a 2x10. Now, one nice thing about the deck details, and one nice thing about providing the tables instead of a definite answer, is you actually do have a couple options here. Based on the information I gave, if you change nothing, you would have to use a 2x10 joist. However, if you go back to the example and you see that on one side you have a 2-foot overhang and on the other side you have a 2 foot 6 inch overhang, assuming there's not some obstacle there that would prevent you from moving the beam location, you could potentially reduce your overhang on the front of the deck to 2 feet 3 inches and increase your overhang on the back of the deck to 2 feet 3 inches, and you would still be able to use that 2x8 joist. So there's a lot of flexibility that is also built into the deck details to allow you to modify your deck to your needs. So we know that joists support the decking. What supports the joists? Beams. And when we talk about beams, we talk about influence width. Influence width is the area of the deck that the beam is supporting. In this case, if you look at the top left example here, you'll see that that outside dropped beam covers half the distance from the span on the left and the entire distance of any overhang or cantilever. So if we had a 10-foot joist span on the left side of that beam and a 2-foot cantilever, you would end up with a 5-foot width on the left and a 2-foot width on the right to give us a total of a 7-foot influence width on that beam. And if you go through each example here, you'll see how we derive that influence width. But essentially, it is half the distance between supports and any additional cantilever or overhang. When we talk about designing beams, the deck details covers 2 and 3 ply beams. And what do I mean by ply? Well, a ply is each individual member. So if I talk about a double 2x10 beam, I'm talking about 2 individual 2x10 boards that are fastened together to create a beam. A couple rules of thumb that you need to keep in mind with beams. If your total beam length requires you to splice or divide the boards because you can't purchase a board that is long enough to make that entire span, you have to ensure that all your splices occur over top of a post. If you don't support a splice over top of a post, you create a weakened point in that beam that is going to cause that beam to be significantly weakened. You also have to ensure that the beams are fastened correctly. So in this case, we are talking about spacing that is a staggered pattern, so an offset pattern of either 10D nails or number 10 3-inch screws that are spaced a maximum of 16 inches on center. And if you are utilizing a 3-ply beam, you have to ensure that you have fasteners on the outside of each beam. Now, the reason that we require that beam to be fastened on the exterior is, unfortunately, our inspectors do not have X-ray vision, so they can't ensure that fastening pattern by just looking at the beam. So with 3-ply beams, if you fasten 1 ply on one side and another ply on the other side, ensure that those fasteners are outward facing so that the inspector can verify the locations. So we have another table, and this one looks a bit small. It's because there's a tremendous amount of information on there. And again, that is to try to maximize the situations where you can utilize the deck detail. So for table 3, you have a couple items that you have to know. One is the beam influence that we talked about earlier. And on that left side column, you'll see where we go up to an 18-foot beam influence. And then at the top, it talks about the longest beam span length. And when we talk about the beam span length, it's just like a joist span where you're going from support to support, or in this case, from post to post. So that starts at 6 foot and also goes up to 18 feet. And then once you know your beam influence and your beam span length, you would be able to identify what your minimum beam size is. And I do emphasize the word minimum because you are always able to go bigger. You just cannot go less than. So, because that is such a big table, I want to go through that real quick to ensure that we're covering all the concepts there. So in this example, we have a deck that is 12 feet deep by 16 feet wide with posts that are 8 feet on center. So let's size that beam. So what we're going to do is we're going to an 8-foot spacing because we know that's our longest beam span length. And we're going to come down to 8 feet for our beam influence. And the reason we're doing that is we go back to this 12-foot span. So we have half the distance between 12 foot, because those are our 2 supports. We get 6 feet plus a 2-foot cantilever to give us a total of 8 feet. So we go to 8 feet for our beam span length, and we go to 8 feet for our beam influence width to get a minimum beam size of 2 2x12s or 3 2x8s. So next on the list of carrying the loads down are your footings and posts. So just to reiterate, we have deck boards are supported by joists, joists are supported by beams, beams are supported by posts, and then posts are supported in the ground by your footings. So let's talk about footings real quick. The requirements for your footings in Fairfax, you have to get below your deck, your frost level. So in Fairfax, to get below that frost level, you have to go a minimum of 24 inches below grade. So while we haven't had a really good frost in a while, what has been identified for this area is that the frost line does not go below 24 inches. The reason you have to go below that, if you look at the picture here at the top right, you'll see when the ground freezes and you end up with this condition called frost heave, if your footings aren't below that, that measurement, you open your deck to the potential of buckling. If you look there, you see that hinge point that's created at the post and beam creates a buckle, and it shifts the deck completely. So you have to ensure that you're below the frost level to prevent that frost heave effect. Another thing you have to ensure is that your footing is situated on solid bearing soil. When you have problem soils, or you have a situation where the area that you're digging was previously disturbed, you may not have solid bearing soil. And the way that the inspectors end up testing that is using a soil probe to come out and verify that the soil is compact and not loose or a problematic soil. So the only area that is typically easily identifiable as problem soils are soil that is within 5 feet of your home's foundation. Because of that, we require that footings that are located within 5 feet of your home's foundation have to go down to your home's, the house's footings. So yes, in some situations that does mean a very significant hole. But that is to ensure that it is not only on undisturbed soil, but also, depending on the size of your deck, that it is not going to impose extra load on the house foundation itself. Another potential hazard for footings and why it's important to always call Miss Utility, 811 Miss Utility, before you dig is homes have underground utilities and other unknown and potentially hazardous cables underground. So always call Miss Utility before you dig. They will come out and mark your utilities. And when you dig, if you come up to a situation like you see here in the bottom right, where there are your utility lines in there, you have to be aware of a few certain items. Never pour concrete directly against a utility line. That is a very bad mistake. Please do not do that. What you can do is either dig below that utility line and place your concrete below that utility line, or you can install a barrier, whether that be a sonotube or some other barrier that would prevent the concrete from directly adhering to those utility lines, because that's where the real hazard is. You also cannot place a post or footing directly on top of a utility line for hopefully obvious reasons. Table 4, another large table. Table 4 covers your footing type and maximum height. And when I say footing type, that will reference you to a size on table 5 that we'll cover here in a second. Again, if you look on the left side column there, we go back to that beam influence width, and across the top, the beam span length. So those dimensions are important for not just table 3, but table 4 as well. What you'll see here is on the left side of the columns, you'll see footing type, and it'll give you a number A through G. On the right side, you'll see a maximum post height. That maximum post height is the dimension from grade to the bottom of the beam. So once we get that designation from table 4 for your footing type, you'll take that to table 5 to get your footing size. In this case, you'll see we have footings as small as a 12-inch square footing up to as large as a 29-inch round footing. And all that depends on the area, again, the area of the deck that is being supported by that post and footing. Once you know the size of your footing, you have to determine what type of footing you want to install. the deck details provide you three options. One is filling the entirety of that hole with concrete and using a base connector, one similar to this, that would end up being cast into, either cast into or installed after, that holds the post and connects the post to the footing. The benefit to using a connection like this is it keeps your post out of the ground and away from water. The number one enemy to wood construction is water, especially in outdoor applications. So the benefit to using a base connection is that you can keep it out of the ground and away from water as much as possible, any standing water. However, you do also have the option of encasing your post in concrete. And this is a situation where you would pour the base and then set the post in the hole and then finish filling it up with concrete. The importance of either using a base connection or filling it in with concrete is you are trying to prevent uplift. And when I talk about uplift, that's the effect of wind essentially sucking your structure into the air. Think a video you've seen on YouTube where you see the strong winds carrying the trampoline away. That is a situation where you see the wind sucking up that trampoline and blowing it away. Other items that are code compliant but outside of the scope of the deck details include helical piers, footing plates, and a fairly newer product called a diamond pier. And while all of those are perfectly code compliant, they are outside of the scope of the deck details and therefore would require a plan submission for approval. So, code compliant, but prohibited per the deck details. Once we have sized our posts and footings, we need to go back and shore up a couple other items. In this case, we're talking about your post size and your post to beam connection. We talked about our joist to beam connection, but this is your post to beam connection. So in this case, per the deck detail, any deck that is greater than, that has a post height greater than 30 inches is required to use a minimum 6x6 post. To attach the post to the beam, you have two options. If you're using a 2-ply beam, you can notch your 6x6, as seen in the top left here. You have to ensure that you have a minimum of 2.5 inches left of the 6x6, and you would notch down so that the beam can sit on the post. And you would fasten that beam to the post with 2 half-inch diameter through bolts. The importance of that is ensuring that there is enough meat left on that 6x6 so that it can actually resist the exterior forces and achieve what you're hoping it achieves. If you are using a 4x4 because your deck is less than, your deck post is less than 30 inches, or you're using a 3-ply beam, you would end up using a post cap connection like this one. So this is a one that you would use on a 4x4, but what you see here is the bottom here sits on top of the post, and you would sit your beam directly in this saddle here, and you would fasten it through these holes that are these pre-drilled holes. The one thing that you cannot do, it is not only is it no longer code compliant, but also prohibited per the deck detail, is what is known as a split beam connection, which is shown here at the bottom right. It was a very common practice probably 25 years ago that instead of notching the post, you would just sandwich one ply of your beam on one side of the post and the other ply on the other. And while there are still applications where that connection may be perfectly fine, the problem with it is it significantly reduces the capacity of the beam. When you sit the beam directly on top of the post, you are using the beam to support the weight. However, with this split beam connection here, you are depending entirely on the through bolts to hold up that weight, because the post is providing very little in ways of support. Another review. In this case, now we're going to size the footing. So what size round footing do you need for that center post? We go to table 4. Your longest beam span is going to be 8 feet. Your beam influence is going to be 8 feet. So we end up with a footing type C and a max post height of 14 feet. Once we know that footing type C, we go to table 5 and we look under the round footing column and type C to get an 18-inch round footing with a minimum thickness of 6 inches. Another extremely important connection for your deck is when you are using ledger boards. A ledger board is a bearing connection between your main structure, house, and the deck. The ledger replaces one of your beams. A couple key factors to keep in mind for your ledger include your ledger board depth has to be greater than or equal to your deck joist depth. So if you're using a 2x10 deck joist, you have to use a minimum of a 2x8 ledger. Another thing to keep in mind is that if you are using a larger ledger than deck joist, that it has to be a top flush connection. So the top of the ledger board and the top of the deck joist have to be on the same elevation. We do have a few approved ledger attachments built into the deck details. One of which is when you are attaching a ledger directly to your house band joist. The band joist is similar to the rim joist that we talked about earlier, except for the band joist sits on top of your foundation on the exterior of your house. You have to ensure, the one thing that is most important, and we will get a little bit deeper into this here in a second, is flashing. Anytime you penetrate your house, you put a hole into your house, you have to ensure that you are properly flashing it to prevent moisture and water from getting in there. Another common ledger attachment that we have a design for are ledger boards into a solid foundation wall. This would be where you're attaching your ledger board to your basement wall, and it is solid concrete. You also have an option to install a ledger attachment to a concrete block, a hollow masonry block wall. And while this is probably the least common attachment we get, it is probably the most important to follow the details on, because it is the easiest to mess up. There are a few conditions where ledger attachments are prohibited and you have to utilize a freestanding deck or get an engineered design. In this case, we're talking about attachments to engineered open floor trusses. So if your house was constructed with engineered open web trusses, you either need a freestanding deck or a engineered design for your deck. And the reason why is floor trusses are designed only to carry the load that they were designed for. And very rarely are they pre-designed to carry a deck. And if they are, you would have to provide some kind of documentation showing that. Another prohibited attachment is ledger attachments to brick veneer. And brick veneer is different from a solid masonry wall. Brick veneer is strictly a wall covering on the exterior of your house that is not a structural element. And the problem with trying to attach to or through brick veneer is that there is an airspace behind that brick veneer before you get to the structural elements of the house, that when you tighten that ledger down, you are compressing that brick and weakening that veneer. So it is prohibited per the deck detail, and would require some kind of engineered solution if you still wanted to use a ledger attachment. The third and final prohibited, specific prohibited ledger attachment is to an overhang. If your home has an existing cantilever or overhang, you cannot attach a ledger to it. Similar to the open web floor trusses, where though the cantilever joists on your home were not designed to carry this additional load. So you have to either provide a freestanding deck or some engineered solution showing how those joists can carry that additional load. And just like with the footings, we have a couple situations here highlighting situations that we found where those are issues. One item I would like to pull up is a few companies, in this case specifically Simpson Strong-Tie, do have products that advertise the ability to connect through brick veneer. This product down here on the left is a Simpson product, and while we will allow it per design, we do not allow it per the detail. So if you do wish to utilize a product like that, you would have to get an engineer to create a design to account for all the additional loads and to show how that bracket is going to support the load of the deck. If you are replacing your deck and you remove the existing ledger and you see that the rim joist or the band joist is completely eaten up and rotten, you cannot cover that back up. I know that seems fairly obvious, but if not, please do not cover it back up. And then on the right there, you see an example of attaching to a cantilever. Even though it's not a very deep cantilever, it is still a cantilever, and it is still not designed to carry that additional load. Going back to flashing, as I mentioned, anytime you are putting any hole into your house, you have to properly flash or cover up that penetration. So flashings at the ledger board connections. And I would also like to point out that if you're doing a freestanding deck and you still want to attach an end joist or a rim joist to the house on the back side of that deck, that still would require flashing because you're still putting fasteners into the home. So even though you're not utilizing it as a bearing member, it still needs to be properly flashed. So flashing at ledger board connections, they either have to be copper, stainless steel, or UV resistant plastic, or galvanized steel. There are a few products out there besides roll flashing, which you'll find typically in large rolls, something similar to this. It comes in a roll where you just unroll it and end up tucking it up underneath the siding and over top of the ledger. It's just this is just a UV resistant plastic, or a product specifically molded like this one, where you can see from the side profile here, this goes up underneath the siding and nailed in place, and it sits over top of the ledger to allow water to come down, go over top of the ledger, and then out away from the house. Some other items to consider. That flashing is more designed for homes where you're doing a wood-to-wood connection. If you are attaching your ledger directly to a concrete wall or masonry wall, you have to provide some kind of silicone or some other water barrier at the top of that ledger to try to force the water away from the ledger. Only the fasteners noted in Table 6 are allowed to be used for ledger attachments. One thing I want to emphasize is that lead anchors are prohibited. Again, another material that used to be very commonly used are prohibited under the current deck details. When the county inspector comes out to do your inspection, they are going to ask that you verify what you are attaching the ledger to. So if you are attaching it to the house band joist, you have to verify what type of material that is, whether it's a 2x material, whether it's an engineered wood product. You will have to be able to identify what that material is. And that can be done through a couple different ways. If you have an unfinished basement or crawl space, and the inspector would be able to verify it from the inside, you can use that. Another common practice with some of our deck builders is they will take a hole saw and they'll core out a piece of the rim joist to show the inspector. But somehow you're going to have to be able to verify that for the inspector. The general tenets of the fastening spacing come through this example here, where you see you're required to have 4 fasteners at each end of the ledger board. And this isn't each end of the deck. If, again, you have a deck that is so long that you have multiple members of the ledger attachment, each end of that, each individual board would have to have those 4 fasteners. And then your spacing is going to be based off of Table 6. In Table 6, we see the ledger board fastener spacing. It's once again based on your joist span, because again, we're talking about what area of the deck is being supported. And then depending on which fastener type you wish to use, whether it's lag screws, through bolts, or any number of engineered products, engineered fasteners. And then your band board material, which is why it's important to verify whether it's an engineered wood product or 2x lumber, will tell you exactly what your spacing needs to be. Running through a quick example, what maximum spacing is permitted. We have a deck with a 12-foot joist span, and the band board was confirmed to be 2x material. So we go to Table 6. We'll go to that 12-foot joist span. We'll go using a Fasten Master 1/4-inch ledger lock wood screw on 2x lumber would tell us that we need to have a maximum spacing of 12 inches on center. Now this is on top of your 4 fasteners at the end of each ledger. At this point, we have covered all of your gravity loads. And now we'll go into your lateral loads. So I mentioned earlier with the hidden fasteners, the idea of creating this rigid diaphragm, this solid framing to prevent rotation. You're also required to provide lateral support to not only prevent rotation for left to right, but also racking at the top of the deck as well. And that's what we're covering here in Table 8. It's based off of your post height. So the higher up you go, the more rigid the structure, or the more bracing is required to keep the structure rigid. So post heights up to 2.5 feet, you don't need to provide any. The idea here is that it's low enough to the ground that you shouldn't have too much left to right rotation. Posts up to 11 feet in height are either going to require methods 1 or 2, unless it's a freestanding deck, in which case it's going to require method 2 and 3. And post heights up to 14 feet, potentially you need multiple methods. So what are these methods? Well, method 1 is tension ties. And what is a tension tie? A tension tie is this fastener right here that gets fastened to the side of the, fastened to a deck joist and into the base plate of your home. And what that does is help resist that lateral displacement that we were talking about. If you're going to use this method, you have to install a minimum of 4 tension ties, 1 at each end of your deck, and then 2 more equally spaced in the middle. The fasteners penetrate a minimum of 3 inches into the sill plate or the top plate of a wood framed wall, depending on where you are installing this. And if you are installing into concrete or a solid masonry wall, you can substitute the fastener for a expansion bolt. If you look at this display here, you'll see that it can be installed either at the bottom of the joist or the side of the joist. And there's even a case where a brace can be installed to lower it even more. This is by far the most common method, as it is the most visually appealing to homeowners when it comes to meeting those bracing requirements. But if you are more of a traditionalist, you can still absolutely use the knee bracing method, which is what method 2 is. Method 2 covers the bracing of the post to the beam, and you have options of using 2x knee bracing, 2 feet out and 2 feet down, or you can use a 6x6 and brace it 3 feet 7 inches down and 3 feet 7 inches over. Please note that if you're using the knee bracing, the 2x knee bracing, it has to be on every post. But if you're using the 6x6 knee bracing, it can just be on the 2 end posts. Method 3 is very similar to method 2 in it's still knee bracing, but in this case we're talking about bracing from the post to the end joists. So in this case we are talking about bracing back from the post to the closer to the center of the deck. So method 2 talks about bracing at beam locations, and method 3 talks about bracing back towards the center of the deck. And again, all this is to help rotate or help prevent the rotation and movement of the deck. A great example of why this is important is if you've ever walked across the deck and instantly felt it moving underneath swaying underneath your steps, that is the motion that we're trying to prevent here. How do you connect these? So you can either connect members to the front and back. At center post, you can either connect a brace to the front of it and a brace to the back of it using the alternate bracing, or you can bring them both to the front or both to the back, and they would end up being fastened with wood screws that are approved in Table 6. So we had those engineered products. So you do have to use an engineered screw, or you can use two 20D nails. If you have to add blocking, because it's offset by just enough, you end up using 2 rows of 10D nails for a total of 10 nails, or number 10 screws. If you opt for the 6x6 connections and you utilize through bolts, there are provisions here for how to attach those through bolts. One thing I'd like to point out, because it's an often asked question, is this location of connecting a 6x6 brace is the only location in the entire deck detail that allows for recessing a fastener into the members. That is an important distinction because we often get questions about recessing fasteners in beams or in other locations. However, the joists, beams, and all framing members are sized specifically based on the full amount and the full width of that member. So if the plans call for a double 2x10 beam and you end up recessing a fastener 1/2 inch or 1 inch into that member, you no longer have a 3-inch wide beam, which is what it was sized for. Now, if you opt to upsize and you wish to use a 3-ply 2x10 beam so that you can recess that member, that is perfectly acceptable. You would just have to make sure that the inspector understands that that's what you did, because they are trained to identify that potential hazard and may write that as a infraction. Next, we're going to cover guards. The first thing that you have to determine when we're talking about guards is one required? Guards are required where any portion of the deck is greater than 30 inches from grade at any point measured 36 inches from the edge of the deck. One benefit to using the Fairfax County deck detail is that we provide a pre-engineered solution for your guards. If you look at figure 34, you will see that it provides you all the fastening requirements, all the picket spacing, the distance between guardrail posts, and completely covers how to assemble that guard. If you choose to go with another product, that is perfectly acceptable. You would just have to provide whatever evaluation report or engineered design that you're utilizing. If you look at this picture right here, you can see where you may have a situation where it is compliant everywhere at the perimeter of the deck, but as soon as you go a foot off of that deck, you end up with this large drop-off, and it creates a hazard even if it is not at that 36-inch mark. Well, the most important aspect of the guardrail design is your guardrail post connection. The information that we've provided shows how you would attach the guardrail post to the substructure, or in this case, the deck. The most important thing to note about guardrail post connections is you cannot, in any situation, notch a 4x4 guardrail post. And it goes back to that principle we were talking about with the posts, the post to beam connection, which talked about, where I talked about making sure that you leave enough meat that the member can act the way it's intended to. And if you notch a guardrail post, it is not going to be, it's going to create a weakened point at that notch that's going to cause that post to fail. So each guardrail post is required to have a hold down connection that looks something like this. So you have this 1,800-pound winged connection here that ends up being attached to the joist or block, and the post, and the bolt goes through the guard. This creates a very secure connection which limits the movement at the top of the post to achieve the required capacity. If you look at those lower examples there, they give you different scenarios, whether it's on the side of the deck or the end of the deck, so whether it's being attached to an end joist or a rim joist, or if your post doesn't fall directly at a post location, it gives you a scenario of how to fasten that in between joists. Another theme that we've covered a lot today is code compliant and allowed per plan, but not per detail. So these cover popular trends like surface mounted guardrail posts. In most cases, they're perfectly code compliant, but we don't have a design in the deck detail. And the main reason we haven't provided a design at this time is there's such a variation in products that it's hard to give a one-size-fits-all solution to these surface-mounted guardrail posts. And because of that, you would have to submit a set of plans to provide how it's being attached and what size fastener and the product specifications. Another item that is popular, but not in the deck detail, are glass rails. Again, the right product is perfectly code compliant, but you're going to have to demonstrate how that meets code through an evaluation report or through engineering. And same with custom fabricated rails or rails that are built on site. We've now protected the deck itself. Let's talk about how you're getting on and off that deck. Stairs and landings. Decks that have stairs provided have to be a minimum of 36-inch wide, and a single set of stairs is allowed up to a maximum of 12 feet without a landing. If you exceed a 12-foot height, a landing must be provided to break up that single run. You also have some stair geometry to keep in mind. Your stairs can have a maximum of an 8 1/4 rise. So every time you pick up your foot, it can't go more than 8 1/4 inches. And you have a minimum of a 9-inch tread, which means the width of the stair can't be smaller than 9 inches. Other things to keep in mind is that a nosing is provided on each stair between a 3/4 and 1 1/4 depth. And the nosing is the distance from the riser to the edge of the tread. Most designers opt to provide closed risers. However, the way the code is written, it talks about you cannot allow for a 4-inch diameter sphere to pass through any opening on your guards or risers. So in most cases, you'll see an inspector will typically either use their fist or some other dimension to achieve that 4-inch rise. If they can put their fist through it, it's too wide. The only exception to that 4-inch rule is at the distance between the guardrail and the tread, you have a little triangle that's created. that can't allow for the passage of a 6-inch sphere. And all these protections are put in place to prevent accidental injuries from somebody slipping or, in most cases, children getting body parts stuck, whether it's heads or arms or feet. The idea is to minimize the hazard. So the smaller the opening, the less likely it is somebody's going to get injured. When we talk about your stair construction, we're talking about your stringers. And for stringers, the details provide a couple options for attachments. So in this particular case, your stringer is at the bottom is going to either bear on the corner of your landing. And the reason we do the corner is because you're trying to prevent sliding. If you bear your stringers directly on top of the landing, you have a potential for a sliding effect, which we're trying to prevent. So that's why if you look at the detail, you see it notched out so that it can't slide on you. At the top of the landing, you see the stringer attached by a hanger. Now I do want to point something out. This is a specific hanger that is approved for attachment for stair stringers. This hanger right here attaches to the side of your landing, gets bent at a pre-stressed spot to the angle that you need it, and then is fastened not only to the side, but also the bottom of the stringer to have a very secure attachment to the substructure. The reason that you cannot use a regular hanger, as we had talked about earlier, is one, it's not tested for that attachment, but also in some cases, depending on the length of your stringer, exceeds the weight capacity of these hangers. So you have to ensure that you're using the proper connector for the proper application. A couple things to keep in mind when it comes to stringers, especially the width between stringers. For cut stringers, you have a maximum of 18 inches in spacing. But if you are using a manufactured product, a composite wood decking for your stair treads, you have to pay attention because some of those require much more closely spaced stringers. Some products as closely spaced as 8 inches. So just make sure you're paying attention to what product you're using before you place your stringers. If you are using 2x lumber, you can go the 18-inch max spacing and just make sure that you are placing 2 8D nails or number 8 screws at each deck board and into each stringer. For your stair guards, we also provide a design very similar to the guardrails around the perimeter of the deck, but it is important to note that the hold downs are required on the stair guards as well, and that your guard has to measure between 34 and 38 inches from the nosing to the top of the guard. Every set of stairs that has 4 or more rises, and again, when we talk about rises, we're talking not about stairs, but every time you pick up your foot. So if I have to pick up my foot 4 times, every set of stairs that has 4 or more rises is required to have a compliant handrail. In some cases, you can utilize your top guard, the top of your guard, as that handrail. But those are very specific products that you would have to look for. And you have to keep in mind that that handrail has to be continuous for the set of stairs. So if your stairs are long enough that you have to break it up with a post, it would not be able to serve as the handrail, and a separate continuous handrail would have to be provided. The handrails have to comply with returns at the top and the bottom, as well as they have to stick out a minimum of 1.5 inches away from the guardrail if it is separate from the guardrail. For the profiles, you look at this example here, it gives you some very specific dimensions. And the idea is, somebody like me, I can grab a 2x4 and hold myself up, no problem. But the idea is that the idea of code safety is that it protects everybody and it's accessible for everybody, not just the person building it. So in this case, there's some very specific requirements that you have to ensure that your handrail comply with. We've covered the entirety of the deck detail. Let's try to put it all together here. Let's say we're designing a deck that's 20 foot wide by 16 foot deep. We're using a ledger attachment, and we're providing a 36-inch wide set of stairs to the right of the deck. What might that look like? Well, when we submit for our deck permit, you'll fill out the second to last page of the deck details and identify, using this checklist, what you are planning on using. And you're going to provide a very simple set of plans like you see here on the right, highlighting all those. This is both for the ease of the person doing the building and the ease of the person doing the review. In this, you'll see we've identified our footing size, our beam size. We've provided dimensions for the spacing on our footings, the size of the joists, and should be able to build a deck using this information. Once you get your permit and you actually start building the deck, what you can expect from inspections are at a minimum 2 inspections, but in most cases you'll have 3. The first one being your footing inspection. And when you're ready for your footing inspection, that would be the holes are dug to that 24-inch frost depth, at a minimum 24-inch frost depth, and your rim joist is prepped for verification. So you've either used the hole saw to pull that out, or you're going to have access to the unfinished portion so that the inspector can verify. That's the place in your building process that you're going to stop and call for an inspection. The next inspection is going to be your framing inspection. That's where you have your posts installed, your beams installed, your joists are installed, but before the decking is installed. Now, that's not required if your deck is 48 inches or more above the ground. However, I would caution you that if you are using products to cover it up, if you're using wrap to cover up your framing members, I still would recommend calling in a framing inspection because the inspector has to be able to verify all the connections. So it really depends on what your final product looks like. If all the connections are visible, then you can potentially forego your framing inspection and just call in once it's completed. But if it does end up getting wrapped and covered up and connections aren't visible at final inspection, you do need to call in that framing inspection. Once you've passed all those, all that's left to do is enjoy your brand new, beautiful deck. So here are some links for additional information, one of which is a step-by-step guide on how to submit for your permit. One is a link to the Virginia construction codes, and one is a link for more information. I want to thank you for joining me today. If you do have any additional questions or need some more information, please do not hesitate to reach out. We can be reached at 703-324-2529, or we can be emailed at lds-bd-rb-planreview@fairfaxcounty.gov. Thank you very much and have a wonderful day.